Okay, so for those that missed yesterday, Giacomo did the presentation yesterday. In the schedule was not updated, but it was recorded, so you'll find it on the YouTube channel Kamailio World. So for like my technical session at this edition, which I use as the last slot. This year I was thinking to approach a little bit the transport layers, which probably most of you use extensively and you are familiar with. But since we added this multi-threaded UDP receiving mode and a few other related parameters and attributes, I wanted to go over them and might also be good for newcomers to Kamailio, as again the recording stays on the YouTube public for everyone. So yeah, the usual thanks for the sponsors that support us. I'm coming back to it at the end. So the transport layer, actually two categories would be here, would be the address family, so the IPv4 and IPv6, and we support that. We have support for IPv6 since like summer of 2002 because there were some funding in the research area at that time for the new protocol. It took like 20, whatever, 3 years, and we are not yet there, but now most of the modules have good support for IPv6. Initially, it was more like the core transmission receiving traffic. And then for the delivery protocols, I listed here the ones used mostly for SIP. So UDP, TCP, TLS, SCTP, not much use, but we have support for it. I haven't seen any deployment. WebSocket, the unsecured for local testing, we support it, and WebSocket secure. And I'll have some slides also later how you can identify like address family or the type of the protocol. There are a couple of variants. So we have like keywords, which are part of the scripting language, like this AF, so it's not a variable, like now dollar in front of it. We have a couple of such keywords. And then we have also variables that gives you information about the current protocol of the incoming message. Some people think why you need so many transports and where are they useful? Of course, based on some needs, from security to scalability, one is suitable more than the other. Like if you are on the private network or IPsec, as Fred said before, maybe UDP is better choice because it's lightweight. If you are on the same local network, also packet loss is not a problem, so you don't face this additional retransmission complexity and so on. Of course, we are bridging in many cases from this internal to external. Could be because you have devices on the internal network or you want to protect your application server like Asterix, prepaid system, or transcoding or a gateway to PSTN, not to have it on the public internet. So Kamailio, with this multi-protocol support and ability to bridge between, helps a lot. Connecting from older networks to, I put it here, future to make all happy, which is not here. Like the future protocol should be the current one, the IPv6. So you don't need to replace everything at once. You can start building and testing with IPv6 as a different platform, and you can still bridge with the existing customer on IPv4. Switching to secure transport, like when you need to cross the public internet, for example, from maybe one location to another location of your company, or from a data center to another data center regions, and you don't have like a dedicated VPN or wire between. It is highly recommended, and I think Sandro is still here, to use TLS rather than unencrypted UDP or TCP. WebRTC2 classic VoIP with this WebSocket support, and I'll have a link. You very likely will need the RTP engine in the mix. And then you can combine it. So one Kamailio can do all these protocols, and for different situations, different user agent, based on your conditions, you can do all of these kind of services at the transport layer. How you, or what we offer from this point of view, we have this kind of global parameters where you have to specify where Kamailio is listening on, and that will define also what protocols it's serving at that moment. In addition to this 4 SIP, we also have support for the HA proxy protocol, added for some external contributors which like to use these HTTP load balancers from the cloud service providers. And of course, we support the HEP protocol for mirroring, but the main focus was on the, let's say, classic transport protocols so far. And then it's about accessing these attributes either with some variables or keywords, modules parameter that you can use to specify. I gave some example of how you can tell Kamailio to listen on various protocols. So you can give this listen many times. I'll have also a slide later. And also you can specify how many processes to create, because in the case of UDP and SCTP, actually, we have a pool of processes per socket, while the TCP and TLS was more like a single pool of processes to handle the traffic, and an additional, what we refer to it as TCP main attendant, which was managing only the connection, like accepting, closing, or detecting when it's an event, and then passing that connection to a worker in this pool of processes. And we have a lot of parameters. So here is just pointing you. You have the links to the wiki where these core parameters are set to tune a lot of attributes for these sockets. TCP, connect timeout, then connection lifetime, but also for UDP, if it's what's the like accepted MTU, you can also tell it to Kamailio via module parameters if the size of the SIP message is over some size, then it can switch to another protocol, like from UDP to TCP. You can also tell to try to auto-detect which socket is the most appropriate to send out, if you don't want to do this kind of condition in your config file. So, you know, where the target it is, it's in the private network or it's in the public network. And I think from 1N1 at some point, long time, I don't know if Luciano was there, there were some improvements on kind of caching, because this is using kind of temporary sockets, if I remember correctly, like pre-pandemic. You can also specify a different number of worker processes per socket with these workers that applies to the next listen. So we have like children will be global, will be applied to every socket, the value of the how many worker processes to create. And with workers, you can make it individually for the next socket provided with the listen. And with the latest version, practically, because this kind of grammar for defining a listen became a little bit complex with optional advertise name, whether it is virtual or not. And as I was planning to add this multi-threaded UDP receiving mode, I needed additional attributes. So instead of defining in our config scripting language the grammar to become more complex, I added a structure-like global parameter named socket, which you could easily relate its internal attributes like bind will be the address to listen on. Then we have advertise what to put in header, so that will be the public address of that box if it's running on a container or a virtual machine. The name of the socket, which is quite useful for conditioning the config file, and I use it quite a lot, not to compare with the, let's say, IP address that could change from, let's say, production to development or testing platform. You can have different IPs there, but the logic could be done on the socket names. Then we have port parameters. So we thought like if you want to have different port than the default ones, you can set it with this parameter, but you can set it only once, like instead of 5060 to consider 5080. And then the IP addresses will be discovered by Kamailio and will listen automatically on all of them. The automatically listening on all addresses, it's only for IPv4. For IPv6, you'll have to enable this auto discovery of all of them with this auto bind IPv6 that you have to set to 1 or yes, which is an alias for 1. Then this one that I referred also yesterday morning when I kind of tried to explain why we shifted to 6.0 from 5.8. So we have this multi-threaded UDP receiving mode that is controlled by this new global parameter, which actually has 3 values. When it's 0, practically it's the classic old multiprocess for all sockets. When it's 1, is the new multi-threaded mode for all sockets you listen on. And 2, it's where you decide per socket whether it is going to be with a dedicated pool of processes, the classic, the old style, or it's going to be the new style with multi-threaded. So what's this about multi-threading? Practically, when you set that I want to have some sockets with this UDP receiving in multi-threaded mode, you will have to define some workers, and we call them like asynchronous because they will be kind of running in parallel with the classic SIP receiver processes. So you define it with this async workers group, and you can define as many as you want. You assign some name and then how many processes to be created. And then per each socket, you can specify which would be the async group handling the traffic. And here I have with 2 different groups, but you can have another socket and you send to UDP-A the group. So you can have many sockets sending to the same async group. And by that, you can eventually reduce the number of connection to the database. You know, no more allocation of private memory for too many processes that would be created otherwise for each of these listen socket. If you want all the sockets, again, to be with multi-threaded, you set the parameter UDP receiver mode to 1, and you don't have to make assignment. You'll have to define the default group for handling that, and it goes from there automatically. So this would be the diagram of how this concept of multi-threaded receiving mode has been designed, because we have a lot of, let's say, global variables. So this is not like making Kamailio multi-threaded only for processing. It's just receiving the UDP packets in a process that creates threads. And that process, it's pushing to an internal in-share memory queue. And then we have the other dedicated processes in the async group handling it. So practically, we don't have conflicts to access global variables in the same process. So at the end, it's still a single process handling the C message, executing the Kamailio configuration file. To give you an example why I started to implement it, it's a customer was connecting very old PBXs, which couldn't do like authentication, so they're bare bone, and they were supporting like very simple SIP capabilities. And to ensure security, because it was connecting to a cloud, each PBX has to go to a different port. So then he ended up with like 100 something ports to listen on. And then you think, okay, let's allocate a single children. But then you think, maybe you get stuck in a query to give a bit of concurrency, let's put it 2. And then you end up with like 200 and something processes, and then going to the connection and so on, it's gonna cost a lot in resources on that system. And being small PBXs, like less than 10 devices, small shops or whatever, there was not much traffic there. So allocating memory for each process and so on was kind of exhausting or too much complexity. So in that case, this could be useful. And as I said, you can combine. If you have some sockets where you expect not so much traffic and you want to experiment or go with this one, you can do it. And if you have your major, let's say, connectivity with most of your endpoints, you can keep that socket with the classic multiprocess mode. So you can experiment and gradually migrate to the new one if it brings benefits. Otherwise, you can still use 6.0 with the classic style. Because of this need to listen on many ports, is not in this slide, but we have now support in the bind with the socket to give a range of ports. So you can say listen from 5060 to 5080, and he's listening on all these 20 ports without having listen. Now, what are the, let's say, elements that you can use in the config file for checking the incoming transport? So we have the keyword from the scripting language interpreter. It's proto, so again, no $. And you can compare it with other keywords like TLS. So again, it's not a string there. It's a keyword. It's not in between quotes. And you can compare it with this UDP, TCP, TLS as keywords. The variant with the variables will be $PR, and $proto, it's also working. This is the short variant, but there are 2 options that you can use, depending which one you prefer. But then you'll have to compare with strings. And we know that internally, if you are a developer, we assign like a protocol ID. And you might see it in this alias for not traversal, somehow encoded with tildes there. And sometimes it's useful to work with it. So we have the $PR ID as a config file variable. And you see here examples how you do it with the keyword, proto different than TLS, or how you do it with the variable $PR to check if it's TLS, and if it's different, we reject it. That would be the conditions we have here. How you select the outgoing socket? So that's also well known and probably used by many of you. So there is a function from the core, but kind of takes static parameters, so you can't use variables with it. That will be the force send socket. And if you need to use variables, will be set send socket that coming from the corex module. Probably the one from the core could be removed, and the other one alias it with the same name in the future. But so far both of them are there. One accepting variables, which is more flexible, accepts also like static value as a string. But for send socket, it's working with also without codes because it's from the interpreter and doesn't need to have like string parameter, while the module functions, they need string parameters in that case. And there is the option to set the outgoing socket also by name, not only by address, by bind address with set send socket name. And of course, there are variables that you could use for assignment, like $fs and $fsn. So all these do more or less the same, depending what you like more, use one or the other. How you set the outgoing transport, so you want to send out over TLS, TCP, or something else. It's about the address, either in the request URI or in our internal field destination URI. So we have these variables $RU and $DU with other variables related to their components, like $RD, it's the domain part, or $DD will be domain part for the destination URI. But practically here is the syntax. So you'll have to put a transport that you like, equal, and the value, TLS, TCP, whatever you want. Then there are some functions from TM where the name of the outgoing transport is like in the name of the function. We kind of inherited from the SCR project when we merged in 2008, 9. And we kept there, but would be more or less the same kind of behavior. And there is one also kind of generic T-relay2 where you give this kind of socket address, proto, IP, or host, and port. And then you can use some modules. I give here an example with dispatcher, or I listed dispatcher, but I think also LCR and carrier route, you can set the outgoing transport without any problem. And then the management could be done easier through the text file or through the database. If you think about having users registering through different transports, some UDP, some TCP, TLS, or also WebSocket or WebRTC, practically from the config file, you have, of course, this listen or sockets defined for the respective transports, but the magic is done by user location and T-relay, so from the TM module. So if you don't really need to care, selection of the outbound socket as well as setting the request URI, it's done by this lookup location, and then the T-relay creates the connection if it's the case and delivers the message. And it's working also in the case of devices on IPv4, IPv6. This is from the signaling point of view. Of course, when you bridge this IPv6, IPv4, you need RTP engine to bridge also at the RTP layer. But from SIP point of view, Kamailio takes care automatically with these ones. I gave here an example because it's quite common these days how you could bridge TLS to UDP. As I said, many run the server on the cloud and they prefer that the devices connect over TLS. And behind the Kamailio, which doesn't have to be the register, could be just like an SBC, like an H proxy, changing the transport layer. I typically recommend to do it with dispatcher, even if you have a single box behind, because maybe later you want to add another one. So in the dispatcher or in the database or in the text file, you define the targets, and then comparing with the socket name of the received, you select one or the other groups of the dispatcher and T-relay. So you don't do much in the config file. You just provision in the database or in the dispatcher list file. Of course, you can do it with the config operation. So we have this listen which define or assign names to the sockets. And based on this $RN, which gives the name of the socket where the SIP message was received, you set the outbound proxy address, our internal one, the destination URI via $DU. And also you can set the socket with $FSN, and T-relay will do the rest of creating connection when is the case and delivering the message to the network. Quite common would be this bridging of the WebRTC endpoints to the classic SIP. That will be, again, involving RTP engine and a bit more complex config file, so I haven't put it here, but one of the available projects on the GitHub maintaining such a gateway. You have the link here. I think in the past also from Kobis were some tutorials. Not sure if it's still available, but yeah, this one would be at least from what I could see in the community up to date these days. How the signaling is impacted. So when is bridging of the transport, so like changing of the transport layer, you can see it from Kamailio, like with record route, and typically it's double record route when we have different incoming and outgoing. So I have this R2 on, and we see one is TLS, one is UDP, and as we know, the order practically it was received over UDP going out over TLS. And also you can see indication in the VIA, which is only for outgoing side of the message. If you want to hide it, because for example, if you bridge IPv6, IPv4, and you have some old devices that don't understand IPv6, then look at topos. It can strip, and on the IPv4 side, it's only with IPv4 headers. And on the other side, which probably will understand fine IPv4, you'll have IPv6, so everything is kind of clean from this point of view. But again, remember, when bridging IPv4 and IPv6, you need RTP engine for the calls to do bridging of the RTP packets. How you can check existing sockets and the transports Kamailio it's listening on. There is a RPC command, corex list _ sockets that you can run. Or if you use kmctl srv sockets, internally it's doing the RPC command. It's just to have a simpler format to run in the config file, but behind it's doing the same. And you get the details of the existing or the active sockets Kamailio it's listening on at that time. Sometimes it's useful because if you use the ifdefs and so on, you want to check, I enable that socket now, and then everything is fine. So this is what I wanted to cover, mostly to clarify a bit about this multi-threaded UDP receiving mode, which again doesn't change if you don't want to use it. So it's Kamailio 6.0 is compatible from the transport layer with configs from 5.8, for example, but could help you to save some resources when you have many UDP sockets for whatsoever reasons that could be. Before ending, once again, big thanks to all the sponsors, and special to the PASCOM guys, which were staying in the room most of the time, so they had to be with all the sessions here. But also all the other SIP-gates, SIP-front, Diablo.com, and Federico with Libon, the guys from Mango Voice coming from US as well, Snom with their giveaways, some nice phones, and then Tyler here with DC router, the open source. Simon, David is back. I gave the bottle already, so Rita is the owner. She extracted herself, so she picked up that one. And yeah, Fred with API ban and LOD, Giacomo, Clucon, and we organizing from Asipto here. And yeah, next year, hopefully, the world will run smoother, and we'll be able to celebrate this 25th years of development. The 20th was during the pandemic, so we did some celebration via Jitsi Meet, right? But maybe next year to mark it, because the 30th is a bit far away, right? So we need some reasons to celebrate a bit more than the usual. I do hope that you enjoyed the new venue as well, the services here, the food, the atmosphere, and most important, the content of the presentation. And besides that, the participants, I hope you could connect and find maybe some ways to collaborate or some ideas to go home with. Thank you.